Hi, everyone. Whenever we're presented with a new idea or some claim, we tend to have very rapid, almost automatic internal evaluations of that claim, often before we've even heard any of the evidence. We will very quickly respond with, "This makes sense," or "That doesn't make sense," and give significant weight to this intuitive gut reaction response, and even continue to hold on to this evaluation when later evidence either doesn't support or actually contradicts this initial intuitive response. You yourself may have made a quick evaluation right now as to whether you think I'm right or wrong about this. So what I want to do in this video is talk briefly about how intuition comes into play in evaluating claims, specifically scientific claims. What we mean when we quickly respond to claims by saying this makes sense or this doesn't make sense, and identifying when our intuition can be helpful, when it is not helpful, and when it is actually detrimental to our ability to evaluate different kinds of claims. This is going to delve a little bit into the role that psychology plays in evaluating claims, and let me say right off the bat that I am not a psychologist. There is a massive and fascinating branch of psychology focused on decision making and how we evaluate claims. And while I've tried to do quite a bit of reading on these topics, I am in no way an expert. So what I'm presenting in this video is limited to how intuition regarding scientific claims can be helpful or harmful based on some of the things I've read related to psychology, and in the description I'll include all sorts of links for resources that you can kind of check through yourself, as well as my own experiences with students in how they respond to scientific claims. Now, intuition is used in a lot of different ways in different kinds of contexts. So what I'm specifically wanting to focus on is intuition as the quick gut reaction, unconscious response that we have when presented with a new claim or data or situation. This initial reaction generally happens too quickly for much detailed analysis of any evidence or even conscious thought to have occurred. So that doesn't seem to be what's generating these intuitive responses. Our intuition seems to be primarily based on our past experiences and patterns that we've identified, or at least think that we've identified, in those previous experiences. When we are presented with a new situation, our brain seems to try to quickly and automatically map that situation onto similar situations that we've seen before, and tries to generate a kind of fuzzy, approximate inductive response. The world worked the same way yesterday as it does today, and we assume that it'll work the same way tomorrow. So we use these prior experiences to generate these quick and automatic responses to new situations, rather than always needing to expend the effort or concentration to actively focus on every single thing around us. So it does have an everyday benefit of allowing us to have these quick responses to new kinds of situations. And there's actually substantial evidence that these automatic responses govern much of our thoughts and actions, more than we generally want to admit to ourselves. Things in psychology like dual process theories, the idea that we process things sometimes subconsciously and sometimes consciously, and there seem to be two different systems to do that. It's referred to as System 1 versus System 2 in Daniel Kahneman's book, Thinking Fast and Slow, which I highly, highly recommend. System 1 being the quick, unconscious, kind of automatic response, and System 2 being a much more effort-requiring conscious analysis. Other things like studying various kinds of cognitive biases, things like belief persistence, and even looking at fMRI studies that target which parts of the brain are being activated when we are generating these quick automatic responses and when we are doing more conscious tasks of like thinking through these steps in a logical argument. Different parts of the brain are lighting up during these different events. And again, as I said, I'm not an expert in any of these, but I'll leave links in the description for resources I've found. And again, these researches are fascinating, so please let me know if you want me to cover some of these ideas more specifically. But even though these intuitive responses can be helpful in familiar everyday situations, intuition is not a reliable method of gaining an accurate understanding of some new phenomenon or evaluating a new claim. Intuition isn't evidence, it's not an argument, it's not a demonstration. We know that people's intuition can be flawed and that different people can have different intuitions about the same kind of situation. So when someone has an initial response of this makes sense or that doesn't make sense, that initial reaction on its own shouldn't be convincing. If your reaction is based on prior experiences or prior patterns that you found, you would have to actually demonstrate that first those patterns that you think you've identified are actually accurate and that they apply to this new situation in the way that you think they do. Those would all require their own demonstration. So again, intuition isn't evidence, it's not an argument, it's not a demonstration. It's just your quick reaction, your personal quick reaction to some new phenomenon. Now, this is not the same as a case where someone has gone through the details of a model and identified inconsistencies or contradictions and then made an evaluation. We might still use the phrase, "this doesn't make sense," if we were to find such an error, but that's not what I'm referring to as intuition, and I want to avoid equivocation. There's a huge difference between the quick, intuitive evaluations that people make automatically and the conclusions that are reached after detailed analysis of the relevant evidence. You might also ask, if intuition isn't evidence or a reliable method of reaching an accurate conclusion, why do we need to talk about it? Can't I just end the video here? Intuition is not reliable. Done. Well, like it or not, these intuitive responses seem to be a built-in part of our psychology and do affect how we evaluate claims. So it's in our best interest to understand a bit of when our intuition is more or less useful and how we can attempt to train our intuition to be more useful. So when is intuition useful, or when can we have a higher confidence that our intuitive responses are going to be more accurate? Well, there seem to be a couple of key criteria for this. First, we need to be looking at situations that are very regular, where we have lots of prior experience. This could be everyday situations, even things as simple as interpreting facial expressions, understanding simple sentences, catching a ball, things like that. Things that involve the rapid analysis of information that's being presented and coming up with an internal interpretation of what's going on and being able to make predictions based on that. So for example, in interpreting facial expressions, if I just make a facial expression, like let's say, then even though I made that facial expression for less than a second, you'd probably be able to identify that, oh, that's an expression of anger or some other kind of similar emotion. Hopefully my acting abilities are good enough to be able to represent that. But you don't have to go through and think, oh, what is he doing with his brow, or what's he doing with his mouth, and what emotion is that being meant to convey? It's almost automatic in processing that as a particular emotion. Things like understanding simple sentences when you're reading a sentence. You don't have to do a lot of conscious thinking about what each one of those words mean. If you know how to read, then you're able to put those pieces of information together fairly accurate to get a general picture of what's going on. And you can even look up online examples where the letters of some of the words are jumbled up. And even though that sentence has words with jumbled letters in it, you can still fairly easily read what the sentence is trying to say. You can look those up online. Things like catching a ball or a thrown object. If someone throws an object, you have very little time to process what's happening physically to that object. But on very little information, you can get a generally accurate prediction of where that object is going to go, and you're able to catch the object. So again, these are all situations that are very regular where we have lots of prior experience. Another example would be estimating certain kinds of quantities very roughly and only in familiar cases where we have familiar units as well. For example, if I had a question where, let's say there's an object, a ball at the top of a 2-foot ramp, something like that. And I don't know, when it rolls down the ramp, how fast is it going to be going at the bottom of the ramp? Well, if it's only 2 feet high, and I have a decent understanding of, that unit of how long a foot is, then I can probably say with fairly high confidence that the ball at the bottom is not going to be going at 50 miles an hour. It's also not going to be going at 0.1 miles an hour. As long as I, again, both understand feet, the distance unit of feet for how tall the ramp is, and I also understand the units of miles per hour, whatever I'm measuring that velocity in. If I instead use things like inches per year, a unit that I am not familiar with, well, I'd have a much more difficult time in coming up with any sort of intuitive response for that because I don't have that prior experience. That prior experience is key in being able to develop a more useful intuition. That being said, we can actually train our intuition to become more and more reliable. I talked about someone catching a ball or catching a thrown object. Well, athletes or people that play sports have much more experience with these kinds of objects and being able to more and more accurately predict where those objects are going on less and less information. For example, a goalie in soccer might be able to have a pretty good prediction on where the ball is going to go based on how a kicker is starting to move their leg towards the ball. And again, that intuition can be trained. Another example of this would be chess masters being able to look at a chessboard mid-game and being able to very, very quickly narrow down what are some better moves. Maybe spending more time finding what is exactly the best move, but being able to very, very quickly narrow down what are a good set of different kinds of moves that might be better for that particular game. Okay. And what's also key in being able to develop some intuitive responses to these different situations is that prior experience and training includes clear and rapid feedback. So going again back to the case of learning how to catch an object. If you're learning just how to play catch early on, you're not going to be very good at it. Okay, when kids are first learning how to play catch, they're going to drop the ball a lot. But in each one of those instances, they're going to be training their intuition to figure out if the ball is moving in this particular way, where does it seem to be going? And every time the ball is missed, well, you see where it went instead, and you're able to correct that intuition. Your mind will build up a more and more accurate model of how those objects move. But again, if you don't have that rapid feedback, then you're not going to be able to train your intuition in that kind of a way. So again, those seem to be the key criteria on when intuition is useful. What about when intuition is not useful? Well, this is going to be the case in situations where we do not have any prior experience. For example, if I'm talking about the properties of the early universe, or what it's like just outside of a black hole, or what happens when you're moving close to the speed of light, or in a system on such a small scale where quantum effects become important, we don't have any intuition. We do not have any everyday experience with those kinds of systems, so our intuition is non-existent for those kinds of systems. We also want to make sure that we are avoiding cases where we don't have clear, rapid feedback in those prior cases. So for example, for long-term political or economic forecasts, you can go on a news network and see all sorts of predictions for what's going to happen politically 6 months, a year, 10 years from now. or what's going to happen economically a year from now, 5 years from now, 10 years from now. And there have been studies that have been done that look at these sorts of political and economic forecasts and find that most self-proclaimed experts in these fields don't have a very good track record. Because if it takes an election cycle before you actually get feedback on whether or not your predictions are accurate, well, that's not enough rapid feedback to be able to train your intuition in those kinds of useful ways. Also, there could be situations where there is inherent unpredictability. Say, rolling a dice. There's no such thing as intuition on rolling a dice because it's a process that has a lot of random parameters. You could say, well, if I knew exactly how the dice was thrown, the exact shape and weighting of the dice, I could exactly predict where that's going to go, but your intuition doesn't have access to those sorts of extremely precise measurements. Other situations where extremely rare but highly impactful events, so-called Black Swan events, will dominate how a system acts, those will defy our ability to make intuitive predictions of how those systems will act. For example, when I talked about long-term economic forecasts, well, the development of a new technology, or say a local, regional conflict or issue disrupting global supply chains, these kinds of events would have an oversized effect on the predictions that we would make about the economy as a whole. And I'd recommend the books Fooled by Randomness and The Black Swan by Nassim Nicholas Taleb to kind of go into more detail on these. Those are both excellent books. I highly recommend them. But again, if we have these kinds of systems that are dominated by these rare but impactful events, our intuition is not properly trained to deal with things that are very rare and very impactful. Another example would be situations where we have very precisely defined terms. When we talk about terms in physics like force, energy, work, pressure, momentum, impulse, all of those in everyday conversations have similar meanings. Their meanings kind of blend together. But in physics, all of those terms have very, very precise definitions and very, very specific properties, and we need all of those specific terms because we want to be able to make very, very specific predictions in physics. But intuition isn't finely tuned enough to be able to notice the differences between some of these specifically defined terms. So those are a bunch of situations where our intuition is not useful. But let's go one step further and look at situations where our intuition is actively detrimental, is actually interfering with our ability to accurately process information. Well, one case of this would be situations where we try to take our intuition from one domain that we're more familiar with and try to force it to map onto some other domain where it doesn't really apply. For example, when I said that we have no intuition about the early universe, we have no intuition about what it's like traveling close to the speed of light or in quantum mechanical systems, if we try to take our everyday intuition and map it onto these non-ordinary circumstances, we're going to come up with problems. And that's going to literally interfere with our ability to analyze systems. Another example would be, let's say I consider a system. Let's say we've got a bar that's on a pivot, and there are some forces being applied to this thing. Well, if the system is static, we can say, well, the forces and the torques that are being caused by those forces have to balance out. So if I have some forces pushing down over here and down at a different location over here, we can talk about how the forces that are applied and where those forces are being applied, how far from the pivot point those forces are acting, those should be balanced in such a way that this bar does not move. It's the static case. But if I have some forces that are acting on this bar and this bar is starting to rotate, we're going through some angular acceleration, then all of those things that we learned about the static case those are not going to apply to the case where this thing is actually moving dynamically, where its motion is changing, it's accelerating. So again, it's the problem of taking intuition developed for one set of circumstances and trying to apply it to another where those rules just do not apply. Another problem tends to occur when we take our intuition developed in a certain domain and try to extrapolate that intuition into other domains where other factors might dominate. For example, flat earthers will say, hey, the earth around me looks flat, it seems flat, I don't feel like I'm moving at all. But that only occurs on relatively small scales. If we want to look at the earth as a whole, we need to look at larger and larger scales where our intuition is just not trained for that. Again, flat earthers might say, well, I don't feel like I'm on this rotating globe. But again, our intuition on when we feel like we're moving is based on things like, oh, am I moving along the ground quickly? Or am I running and I can feel the wind hitting me or something like that? But if us, the ground, the air around us, if all of that is rotating in the same way, is moving in the same way with very low accelerations, well, we're not going to be able to detect using our own senses those very, very subtle effects. But we can detect those with accurate measurement devices, and again, verify that the Earth is in fact an oblate spheroid. Another huge problem with intuition comes from the fact that our past experiences come with many different types of bias. These will influence our perceptions and interpretations of those past experiences, resulting in our intuition being trained on falsely identified patterns. This includes many of the negative things that we think about when we hear the word prejudice, but also includes many other types of cognitive bias. Things like confirmation bias, recall bias, anchoring biases, framing effects, observational biases, and many other types of bias can all affect the supposed patterns that our intuition is being trained on. Consider a simple experiment of me holding up a mass by a string. I've got mass attached to a string and I'm just holding it up. As I hold it, I know from past experience that eventually I'm going to start to get tired. I'm going to start getting warmer, my muscles will eventually start to shake if I'm holding this for long enough. I'm clearly exerting effort and using up chemical energy in my muscles. So my intuition tells me that I must be doing work on this mass when I'm just holding it still. This is a common misconception. The physics definition of work done on an object by a force is the magnitude of that force multiplied by the distance the object moves along the direction of that force. And this tells us that if the object doesn't move, then there is no work being done on the mass. No energy is being transferred to this mass by that particular force. And we can verify this by adding in a support structure. So let's say I have this support structure right here, and instead of me holding up the mass, I'm going to hang this mass from that support structure. Okay? So the mass is now hanging from this support structure. However, using this support point, we can see that as far as the string and the hanging mass are concerned, nothing is changing with this system. Nothing is heating up or undergoing any discernible energy transfer. And again, this, as far as the hanging mass and the string are concerned, this is indistinguishable from whether the object is being supported from this support point or whether I am holding this thing up. Okay. So in both cases, there's no work being done on the mass itself. And I think there are 2 points with this particular problem where our intuition fails us. First, we tend to mix up the terms force and work. When I hold up this object myself, I'm definitely applying a force to the object, but I'm not necessarily doing work on it. And our intuitive processes are not fine-tuned enough to make these two distinctions. Second, when I hold this object in the air, the muscle fibers in my arm are generating a force when nerve signals cause those muscle fibers to twitch. And that process requires chemical energy. Even when I'm holding the object steady, those muscle fibers are still maintaining that tension by continually using chemical energy to go through those twitch motions. And our intuition is generally only attuned to the fact that our muscles are getting tired, regardless of whether or not any of that energy that's being used is actually being transferred to this object. So we get this common misconception based on our biased experience of how our muscles actually work. Another different example that I think falls into this category of when biases are present in past experiences is when I've seen students doing work on homework questions, where after completing some of the easier introductory questions, say something like calculating average velocity from how far an object travels in a certain amount of time. Average velocity is just the displacement divided by that change in time. Some students seem to fall into the pattern of saying, oh, if I'm just given two numbers in the original question, then the answer is going to be what I get when I take one of them divided by the other, or maybe multiplying them together, or maybe adding them in some way. Using one of these operations will probably get me the answer. And I really try to point out to my students that this approach of just trying to guess which mathematical operation is going to get you an answer, that's not a good approach. That intuition of saying, oh, I just have to combine the numbers in these particular ways, that's not going to be reliable. Where instead what you should be doing is looking at what physical principles are going to be applied to the situation described in the question. And should I be using the equations from kinematics describing motion? Should I be using the principles of Newton's laws or conservation of energy or conservation of momentum? Starting from those principles and developing the intuition to know that what I want to start with is one of those key physical principles. That's a much more reliable way of being able to get started on some of these physics questions. Another issue with using intuition is when your intuition interferes with your ability to analyze new data. This is related to things like confirmation bias, belief persistence, but there's a substantial amount of psychology evidence that suggests that when we have an idea in our head, it can be very, very difficult to accept new evidence that goes against that idea. And this is, again, why scientific methods are so important. Scientific methods where we demonstrate that a particular model is able to accurately predict the outcomes of an experiment or not. That requirement on testability and predictability tries to take out all of those parts, or as many of those biased parts of our intuition as possible. So again, when your intuitive response interferes with your ability to analyze new data, that's a very serious problem, and we're only going to be able to address those kinds of problems when we recognize that our own intuitive responses may not be very reliable. So, how can we better use our intuition? Well, a good first point is to recognize that intuition, again, is not evidence. Intuition is just your quick response to some new scenario. It's not evidence, it's not a demonstration of any claim, it's not a method that will reliably get us towards correct answers. And we know this because different people can have different intuitions about the exact same kind of scenario. We also know that there are different kinds of bias that are going to affect that quick intuitive response that we're often going to be giving. So intuition should never override evidence-based scientific methods. In fact, those are what scientific methods are designed to do, to try to avoid these same kinds of bias and the same kind of problems that we have with intuition. We also want to recognize that intuition, while it can be helpful in checking to make sure answers seem reasonable, maybe it raises some red flags on things that we want to check, this is only going to be useful in cases where we have lots of experience and where that previous experience has had fast and accurate feedback. We know that training can improve our intuition for related kinds of questions. But again, that intuition is only making suggestions for us to explore with more robust methods. Okay, it's never going to be the conclusion. And that leads me to kind of the last point that I want to make about this is when your intuition is trying to push your response to be, this is the conclusion to some particular question or some particular claim, this is my evaluation. Instead of having your intuition jump to a conclusion, try to train your intuition to prompt your mind to intentionally reflect on whatever situation you're being presented with using methods that have more demonstrated reliability. Train your mind to say, instead of jumping to a conclusion, I know that some useful methods might be considering if there are alternative ways of interpreting the data, or considering alternative hypotheses other than whichever one is my favorite or the first one that I was exposed to, or considering what other additional pieces of information would help me in evaluating the plausibility of competing models, or trying to identify if there's any fallacies or biases in the analysis that you've done, or to consider whether you would accept it if an analysis similar to the one that you've done led to a different conclusion. Are you just accepting it because it was the conclusion that your intuition first came up with, or was that analysis, whatever analysis you did, was that reliable? Training your mind to quickly respond with these kinds of questions to prompt you to actively dig deeper into considering whether you're using a reliable methodology, in my opinion, that's the best way to train your intuition. So we'll call that one good for now. Again, there's a lot more detail that we could go into with different kinds of cognitive biases, different aspects to this system 1 versus system 2 approach to thinking that I think are really, really fascinating. There's a whole bunch of links in the description that I've put down there for you to look at more resources. If you're interested in me going into more detail on any of these topics, please let me know. But other than that, thank you for the view and have a good rest of your day.